Hi everyone, I am Ashishwi and my teammates are Anjali and Naifa, and we are doing this video under the guidance of Prasad sir, Associate Professor, Department of CSC, SWEC. Our topic of this video is OOPS concept and access modifiers. Now first we are going to explain about OOPS concept. Introduction to OOPS concept. In Python, object-oriented programming is a programming paradigm that uses objects and classes in programming. It aims to implement real-world entities like inheritance, polymorphisms, encapsulation, and etc. in the programming. The main concept of OOPS is to bind the data and the functions that work on that together as a single unit so that no other part of the code can access this data. Let me explain you classes and objects in OOPS concept. Python class. A class is a collection of objects. A class contains the blueprints or the prototype from which the objects are being created. It is a logical entity that contains some attributes and methods. To understand the need for creating a class, let's consider an example. Let's say you wanted to track the number of dogs that may have different attributes like breed and age. If a list is used, the first element could be the dog's breed, while the second element could be represent its age. Let's suppose there are 100 different dogs, then how would you know which element is supposed to be which? What if you wanted to add other properties to these dogs? This lacks organization and it's the exact need for classes. Some points on Python class. Classes are created by keyword class. Attributes are the variables that belong to a class. Attributes are always public and can be accessed using the dot operator. Python objects. The object is an entity that has a state and behavior associated with it. It may be any real world object like a mouse, keyboard, chair, table, pen, etc. Integers, strings, floating point numbers, even arrays and dictionaries are all objects. More specifically, any single integer or any single string is an object. The number 12 is an object. The string hello world is an object. A list is an object that can hold other objects, and so on. You have been using objects all along and may not even realize it. Now let us see how we create an object and how we use it. Creating and using objects is a fundamental concept in object-oriented program. In OOPS, objects are instances of classes which are the blueprints or templates for creating objects. Objects encapsulate data which are known as attributes and behavior which are known as methods into a single entity, allowing you to model and manipulate complex systems in a modular and organized way. Let us see the steps involved in creating and using objects. Defining a class and creating an object which is instance, accessing attributes and methods, modifying attributes, calling methods, interacting with objects, and destroying objects are the steps involved in creating and using objects. Overall, creating and using objects allows you to organize code, group related data and functionality together, and create reusable and modular components in your programs. Objects provide a powerful way to represent and manipulate real world entities and abstract concepts in a structured and initiative manner.
In Python, methods are functions that are defined within a class and are associated with objects of that class. Methods enable you to perform operations on the data of an object or manipulate the object state. In Python, we have four methods, namely instant methods, static methods, special methods, class and class methods. By defining methods within a class, you can encapsulate the behavior related to the class data. and provide a clean interface to interact with objects of that class. Methods enable you to perform operations, manipulate data, implement algorithms, and define the behavior of objects in a structured and organized manner. Inheritance is a fundamental concept in OOPS that allows you to create new classes based on existing classes. In Python, inheritance enables you to define a new class called a subclass or derived class, which inherits the attributes and methods of an existing class called the superclass or base class. The subclass can then extend or modify the functionality of the superclass while also adding its own unique attributes and methods. Here are some key points about inheritance in Python. Superclass and subclass. In inheritance, the superclass serves as the base or parent class, while the subclass is the derived or child class. The subclass inherits all the attributes and methods from the superclass, and others are code reusability, class hierarchy, overriding methods, accessing superclass methods, and last one is multiple inheritance. So, inheritance is very useful when you want to create specialized classes that inherit common functionality from a more general class. It promotes code reuse, improves modularity, and allows you to organize your code in a hierarchical and logical manner. In Python, inheritance is a powerful mechanism that enables you to create complex class relationships and build upon existing code to create new and specialized classes. Polymorphism in Python is a powerful concept that allows objects of different types to be treated as if they belong to a common interface or base class. It allows you to write code that can work with objects of various classes as long as they support the same methods or attributes. Polymorphism in Python simplifies the process of writing flexible and extensible code. It promotes code reuse and enables you to work with different objects in a consistent manner, regardless of their specific types. By leveraging polymorphism, you can write more generic functions and classes that can adapt to a wide range of object types, enhancing the flexibility and maintainability of your code. Now, encapsulation. Encapsulation is a fundamental concept in OOPS that allows you to bundle data, that means attributes, and the operations, which are nothing but methods, that manipulate that data into a single entity called an object. It promotes the idea of hiding the internal implementation details of an object and providing a well defined interface for interacting with the object. In Python, encapsulation is achieved through the use of access modifiers. Although Python does not enforce strict access control like some other programming languages, it provides conventions and mechanisms that encourage encapsulation. Here are the access modifiers commonly used in Python: public access, protected access, and then private access, etc. Encapsulation helps in achieving several benefits like modularity, information hiding, code organization, and code flexibility. While Python's access modifiers are not strictly enforced, it's important to follow the conventions and principle of encapsulation to maintain code clarity, minimize dependencies, and create robust and maintainable code. And next one is abstraction. Abstraction is a fundamental principle in programming that allows you to focus on the essential features of an object or system while hiding unnecessary details. In Python, abstraction refers to the practice of creating abstract classes and methods that define the common interface and behavior for a group of related objects. It enables you to represent complex concepts in a simplified and manageable way. While abstraction, you can create abstract classes that define a blueprint for subclass to inherit form. Abstract classes cannot be instantiate themselves but provide a common structure and set of methods that subclasses must implement. These methods represent the essential behavior or functionality that all objects of that type should have. Abstractions help in managing complexity by allowing you to define a common interface, hiding implementation details, promote code reusability, encourage modular design. In Python, abstraction is often implemented using the ABC module, which stands for Abstract Base Classes. This module provides tools for creating abstract classes and methods. By importing and using the ABC class as a base class and using the method decorator, you can define abstract classes and methods in Python. Abstraction is a powerful concept that allows you to build complex systems by focusing on high level structures and behaviors while hiding the unnecessary details. It promotes code organization, reusability, and maintainability, making your code more modular and easier to understand and maintain. Here are the few examples of OOPs in Python. Let us consider a car. Creating a class for a car with attributes like brand and model and methods like start engine and stop engine. And next one is implementing inheritance in a Jew management system with classes like animal, which is superclass, and bird, which is subclass. And final one is polymorphism in a shape hierarchy with classes like circle, square, and triangle, each having their own methods. And now we will discuss about advantages of OOPs in Python. Code reusability. Classes and objects can be reused in different parts of the program. Modularity and maintainability. Code can be divided into smaller manageable classes. And final one is enhanced data security. Encapsulation provides control over data access. And these are the best practices for Python in OOPs concept. In this session, we learned about some key concepts in Python like classes, objects, inheritance, polymorphism, encapsulation, and abstraction. And also we discussed about importance of OOPs in software development for code organization and reusability. And some more are further resources for learning and exploring Python OOPs.
Now, let us move to further topic, which is access modifiers in Python. In Python, access modifiers are not enforced as strictly as in other programming languages like Java or C++. However, there are conventions and techniques that can be used to control the accessibility of attributes and methods in Python classes. Let's explore the three commonly used access modifiers in Python. They are public access, protected access, private access. It is important to note that the use of access modifiers in Python is primarily a convention rather than a strict enforcement. It serves as a way to communicate the intended visibility of attributes and methods to other developers. However, Python emphasizes the principle of we are all consenting adults here, trusting that developers will respect each other conventions and not directly access or modify private or protected attributes. Public access modifiers in Python. In Python, there is no explicit keyword or syntax for defining public access modifiers. By default, all attributes and methods in a class are considered public and can be accessed from anywhere, both inside and outside the class. This means that public attributes and methods are accessible using the dot notation. Since public attributes and methods have no access restrictions, they are available for use by other parts of the code. While public access is the default, it's good practice to document and communicate the intended usage of public attributes and methods to ensure proper understanding and usage by others who interact with your code. Private access modifiers. In Python, private access modifiers are implemented using name mapping, which modifies the name of an attribute or method to make it harder to access from outside the class. Private access is achieved by prefixing the attribute or method name with two underscores. Private attributes and methods are intended for internal use within the class and are not meant to be accessed directly from outside the class. However, they can still be accessing using the modified names if necessary, although this practice is generally discouraged. However, it's important to note that Python's private access is not as strict as in some other languages. Python does not enforce strict access control, and it's technically possible to access private attributes and methods using their modified names. The use of private access is primarily a way to communicate the intended visibility and discourage direct access from outside the class. Protected access modifiers. In Python, the concept of protected access is not strictly enforced like in some other programming languages. However, there is a convention that can be used to indicate that certain attributes or methods are intended for internal use within the class or its subclasses. The convention involves prefixing the attribute or method name with a single underscore. By using the single underscore prefix, you are signaling to other developers that the attribute or method is intended for internal use and should not be accessed directly from outside the class. However, Python does not enforce this restriction and the attribute or method can still be accessed and used from external code. It's important to note that using the protected access convention in Python relies on the understanding and cooperation of developers who use and maintain the code. It serves as a gentle reminder of intended uses but does not provide strict access control. It's up to developers to follow the convention and respect the intended visibility of attributes and methods. For your better clarity on every access modifiers, please refer specific codes provided in the specific access modifiers. Hereby, I conclude that access modifiers in Python are an important tool for controlling access to class attributes and methods. Public access is the default, while private and protected access modifiers provide greater control over data privacy and code and encapsulation. By using access modifiers effectively, developers can write better design, more secure, and more maintainable code. Thank you.